In this section, we're going to take a look about IPv4 and IPv6 fragmentation and TTL. So let's first discuss what is a IPv6 or IPv4 fragmentation. How does it occur, where it required, and what does this mean actually? So first we need to understand MTU, which stands for maximum transfer unit. A maximum transfer unit is actually the maximum size of packet which can be traveled inside the network. So it actually depends on the media, it's depend on the network, what is size they're going to allow to be sent. So if we go through the line, the largest size of data that can be forwarded in network is known as a MTU. Actually, it depends on type of media, type of network, and sometimes encapsulation as well. Because some of encapsulation, if you're talking about PPPoE, they may going to add some header information. Because of that, the MTU is going to be decreased as the normal MTU, as compared to the normal MTU. So most of the interfaces or most of the network, they allow to send data approximately 1500 of byte, but in some cases they may not allow. So means it, as I told you earlier, it depends on the media and network type. In the situation when you have a two different type of network connected with the router, which have the different MTU. In such case, router broke down packet into appropriate size regarding network and media type so that communication take place. So for example, let me describe this little bit. Suppose we have a three router. This is R1, this is R2 and R3, and this is connected to the serial, and these may goes to the some other uh, for example, let's see, this is gig 0/0, gig 0/0. So the serial interface may allow to send data up to 1500 byte of data, and maybe the interface gig 0/0 may not allow to send data as we can see right there, means 1500 of byte. So router going to detect what I need to do with this packet. Since a computer who is connected right there, and similarly, suppose this is the destination computer. Your computer is not aware what is the MTU size right there. Since I'm directly connected to this interface, I know what is the MTU of this interface, but I don't know what is the MTU of the interface from R1 to R3. So your R2 going to figure out how I need to send this packet in order to take communication. So your router going to break it down into pieces or appropriate pieces so that it can be sent across network regarding destination. So this is what known as the fragmentation. So basically you can say within a line to broke down packet into smaller pieces is known as the fragmentation. It actually based on your network type. You don't require every time to do the fragmentation. So devices do fragmentation when it required actually. So as we go through the example, so what they're doing actually, if a router going to defragment packet, they also going to attach header, which means the source IP address, then destination IP address, and some other information along with this is the defragmented packets actually. They also going to mark that the packet is defragmented. So now the destination device come to know, or a router come to know, the packet is defragmented. So for example, let's see, we have a IPv6 header and we have a payload like too much which cannot be traveled through the network. So in such case your piece going to break down into two 3 or maybe depends on the bandwidth, depends on the MTU size. So they also going to insert a header which is fragmented. So it will be clear once we going to perform the practical on the devices. So now my device is already up and working, and let's say verify what is the default MTU. Actually, if you execute command so interface serial 0/0, so this is the interface serial 0/0, you will find this is actually 0/0/0. You will find the MTU or a maximum transfer unit out every interface. So the current MTU is 51500. You can change the MTU if you required, but in this case I don't require to change the MTU, but for verification, for practical, and for what I should say, for for testing purpose I am going to do on that way. So let's see whether we have a connectivity to the destination device. So this is R1, R2 and R3, and this is the switch which currently I have turn off the MAC address learning, which allow me to the capture information which is going behind the scene. So this is network 192.168.12 and this is 23 because of the using IP address of router. So that makes sense actually. And now this is time to check whether the connectivities exist. So ping 192.168. This is 23.3 that we have connectivity, as we can see 192.168.23.3. As we can see, the data is going from R1 to R2 and then after finally R3. So 12.2 is IP address of R2. And currently there is no changes. I didn't make any change yet. What I'm going to do this, I'm going to send packet from R1 to R3, which is packet size is single, and we'll see the packet going to broke out into pieces and going to send to R3. So what we supposed to see right there, we're going to send single packet, but from R2 to R3 it going to be 2, 3 or whatever you want, or whatever the MTU size is. Based on that they're going to break down into pieces. So let me enable my capture, which is already running, or I should take it again actually. So this is my Ethernet interface which I am connected with. Excuse me. Let me start capture on it. And now I'm going to send a packet. So let's see, ping 192.168.23.3, which is the IP address of R3, and repeat it one time, and then size is this is the default size which I'm going to send. Let me pause and see the ICMP. ICMP originated from 192.168.12.1, which is IP address of R1, and send it toward 192.168.23.1, and we get reply back from 23.1. As we can see, we have a single ICMP packet because the current MTU is 1500, and we have also sent is as it is. So let me change the MTU of this interface. This is R2 connected with gig 0/0. So configure terminal interface gig 0/0 IP MTU, and what size you want to define. In my case, I'm going to put it 500 only, and you can see, you can verify do so run interface gig 0/0. The IP MTU is now 500. So I'm going to Start packet sniffing again. Great. I'm going to send packet again from R1 to R3. So we have sent single packet, but let's see what going behind the scene inside your fragmentation. So let me filter out ICMP only. As we can see, excuse me, let me apply this one actually. You can also see here the fragmented IP. So now we send one packet toward R1 to R3, but we can see from R2 we sending 3 different packets because of the MTU size, and we get reply back as a single packet. So this is what known as MTU, or IP fragmentation. The same case going to apply with IPv6. So you can change the IP, you can change the IP MTU size for IPv6 and IPv4 in order to match the network MTU. So you may need to change it. In my case, I don't need to change it, but for the testing, for verification, I goes through the configuration. The next thing which I'm going to discuss about this video, which is TTL. But before TTL, I would like to show you something else. How R1 come to know the MTU size of link from R2 to R3. From R1 we can use the extended ping so that we come to know the size of MTU of this link actually. So let's say if we're going to ping 192.168.23.3 and we're going to define size, which is 1500, if we're going to send the default size, and as well as using the DF bit, which is going to say that please do not fragment this packet. Actually, please don't break this packet into pieces. If we send this packet to the R3, we can see we getting reply like MMM. This is the actually symbol of CISCO. If you go to the website of CISCO, this is the URL which you can use to get this information. You will see the M stand for could not fragment. It cannot be broken out into pieces. So now we come to know this size cannot be passed across this link. Now we can decrease the size. So for example, which is 1000. Again we getting same kind of the response. So in this time I'm going to use 501. Again same. And now, excuse me, let me send the right one actually, which is 500. Now we can see we getting reply back. So this is how you come to know the MTU size of the link. So now we come to know the size of MTU of R1 and R3 link is 500. That's very good. The next thing which is going to discuss is TTL. So TTL actually prevent layer 3 loops, which is used to prevent layer 3 loops. If somehow R1 sending the default route direction of, let's see, this is R1 and this is R2. Somehow R1 sending default route toward R2 and R2 sending default route toward R1. So they actually going to create a loop. Any packet originated from this host, for example, if it's sending 8.8.8.8 to the default gateway going to send to the default network, and this going to send from R1 to R2 again and again and again, from R1 to R2 and R2 to R1. So they going to create a loop actually. So the loop may become endlessly if we do not have a mechanism which is known as TTL. Even when we sending any packet toward the internet, for example, let me use my command. If we sending any packet like 5.5.5.5 to the internet, it might be 5.5.5 is not available over internet. So your packet is going to discard after certain router. So this is what the task of TTL. So suppose if you send data from R1 to R2, R1 going to decrease the TTL value. The default TTL value is from your computer is 255. Now R1 going to decrease 254, R2 253, and again R3 252, and so on and so forth. At the end, when your TTL reach to 0, now packet going to discard. So let's come with the example so that I can show you the configuration, show you the verification, I should say, the show you the capture packets. So move on to the configuration. This is the topology which I am taken from the GNS, but literally I am running my CISCO gears. So control Y, this is the topology only. And now this is time to verify. Let me close the, what I need to do, I need to configure R2 in order to, let's see, IP route 0.0.0.0.0.0.0 and send to 192.168.23.3. So this is the default route which I am adding on R2. Any network which is not inside my routing table, I am going to send to the R3. So this is the command. IP route 0.0.0.0.0.0. I am going to send 192.168.23.3. And same thing I am going to do with R3. IP route 0.0.0.0.0.0. I am going to send 192.168.23.2. This is the IP address of R2. So let's verify the IP address actually. The gig interface is 23.2. Likewise, do show IP interface, which I have created the alias 23.3. Now, what I'm going to do, I'm going to create a loopback interface loopback 5, and then IP address 5.5.5.5, 255.255.255.255. Let me enable my packet capturing actually on the interface of fast Ethernet. So now running the packet capturing, and I'm going to send data to the, if I'm going to ping 8.8.8.8, and my source IP address is loopback, excuse me, this is loopback, source interface is my loopback 5, and I'm sending data in network. So I'm going to ping 8.8.8.8 and my source IP address is 5. And let's see in in your packet sniffer software, we can see right there the size of packet. So let me pause the capturing since I think they've gone through up to 255 or maybe not. Now here we can see the TTL value actually. So in IP header we supposed to have TTL value is 255 on packet 1, and then packet 2 going to decrease. This is 254, likewise 253, 252, so on and so forth, as we can see right there. At the end, which is going to the 0, then the packet going to discard. So this is what the mechanism which is used to prevent layer 3 loops. So in this video we have discussed about about what? We have discussed about the TTL and then fragmentation. So I send packet from R3 to R2 because let me clear it off actually. I send packet from R3 to R2, which was 8.8.8.8, which destination which I'm looking for. But we know very well in our network there is no destination like 8.8.8.8. R1 seam, R3 seam, I need to send data to the my default route. The same thing happened with R2. R2 also going to send to the default route, which is R3. So it may happen because of the misconfiguration of routing. It may be happen because of some other way, or maybe some other problem is exist. Because of that, the TTL going to work. So on that situation, I should say the TTL going to work. The packet going to discard after 255 hops. So this is all about in this video.